All right, hello everyone. Welcome to my channel. Uh, we do educational videos on this channel, usually focused on some aspect or another of a theory of everything, all-encompassing theories or magnum opuses, paradigm shifters, other important subjects that you have never heard of, but you can't live without them. Once you find out some of these things, they have the potential to change your life because they can reflect upon every aspect of your life. And today is the 390th video that we've done on Dewey B. Larson and his reciprocal system of theory. Mr. Larson was an American engineer, and around 1959 he put out his two fundamental postulates that succinctly expressed his view of how the universe operated. And then he took those two postulates and went through a process of deduction in order to arrive at his theoretical universe. Basically, if my postulates are correct, this is what the universe would look like. And then in his many books, among other things, he compared his theoretical universe with that universe that was empirical, measured and observed and compiled in the laboratories, in the telescopes and microscopes, and of all of the scientists over the course of the decades. And, you know, I don't know how many thousands of scientists, how many, hundreds of years, and how many trillions of dollars were put into all that effort of compiling all those things. But Larson was able to reproduce all those things by himself over the course of his lifetime. And so his theoretical universe matches up very, very well with the theoretical universe, with the empirical universe that the scientists had gradually and painstakingly put together. And that's because, in my view, that Larson was working with an accurate model of how the universe actually worked. And so Larson was able to recreate all of their work because he had the concepts correct, whereas the scientists were just measuring it and observing it, but they didn't know why things were the way they were in many cases. Larson had the concepts. He had the why, and not too far from there to get to the what. Now, Larson's fundamental postulates, the first one is far more significant than the second. And the first one simply says that the universe is composed entirely of one component, motion, existing in 3 dimensions, in discrete units, and with 2 reciprocal aspects, space and time. Hence the reciprocal system. The universe is made out of motion, not matter, not energy, not fundamental forces, but motion. In fact, matter, energy, and force are all just forms of motion. And motion is the relationship between space and time. Space and time are basically motion is basically a fraction, with space or time as the numerator and time or space as the denominator. Time and space can come in multiple dimensions, and they are reciprocals of one another. So time and space are identical, except in their order. They are reciprocals of one another. They do not exist separately. They only exist together in motion. And whatever quality one has, the other also has. You can think, if you are straining your brain to go back to your 5th grade math class or whatever, to remember what a reciprocal is. You know, the reciprocal of 2 is 1/2. The reciprocal of 4 is 1/4. They both have the same qualities. 4 over 1 and 1 over 4, but they are in a different order. And when you multiply them together, you get 1. So 1 is at the center of all reciprocals. And this basically sets up a multiplicative system of kind of balance, whereas the legacy scientists generally use an additive system. So the scientists are measuring from 0, and they can go +1, +2, +3, +4, or they can go negative, -1, -2, -3, -4. But if you have a reciprocal system, you're basically, your 0 point is 1, your origin is 1. And then on the right-hand side, or the positive side, you go 2, 3, 4, 5. On the negative side, you go 1/2, 1/3, 1/4, and 1/5. When you multiply the the two balancing sides, you get 1, which is in the center. And so that is how Larson is seeing the universe, that it's a universe of motion, and the background of that motion, the background of that universe is motion. Now, Larson isn't specifically referring to what we would call vectorial motion, a motion that has a magnitude and a direction, a vector, 10 miles per hour southeast. Larson is referring to a scalar motion, and that is a motion that has a magnitude, but it has no specific direction. And you can envision this using a balloon with dots on it. If you blow up the balloon, all of the dots are moving away from each other. But they're not moving in any specific direction. Every dot is moving away from every other dot. And in fact, even the spots that are not dots, that are between the dots, each location on the surface of the balloon is moving away from each other location. The farther away they are, the faster they're moving away from each other. But they're not moving in any specific direction. They're moving in all directions. From each location is moving away from each other location. That is what Larson would refer to as an outward scalar motion. And that is the motion that Larson builds his universe on. Now, you can kind of see this in this second clause that he had in his first fundamental postulate. The universe is composed of entirely of motion in 3 dimensions, in discrete units. Okay, so time and space both have discrete units, and motion all have discrete units. You have to have a full unit of space in order to have space. You have to have a full unit of time in order to have time. Those are very small units, but they do exist. If you don't have a full unit, then you don't have anything. It's quantized. It's like the concept of the quantum. Now, they're very small. The unit of space is about 4.56 times 10 to the minus 8 meters. And the unit of time is the incredibly small 1.52 times 10 to the minus 16 seconds. But you have to have a full unit before you have it. And if you have 1 unit of space in 1 unit of time, then you have the speed of light. The speed of light is 1 over 1 equals 1. Larson refers to the speed of light as unit speed. And so in Larson's universe, unit speed is the background motion. It's that center, that 1, that is the balance between the reciprocals. So when you have 0 in the reciprocal system, or nothingness, or the null point or the neutral point, the origin, the ether, what Larson calls the progression of the natural reference system, that is moving outward at the speed of light in all directions. So when you have complete stillness in this universe of motion, you have motion moving outward at the speed of light in all directions. It is unobservable. And if you can get with that, and you can get with the idea of motion without anything moving, then you can start making headway in understanding the universe, according to Larson. And then, the way that the kind of the illusion of time and space comes what Larson calls coordinate space and coordinate time. This is the three-dimensionality, at least one of the three-dimensionalities in Larson's universe, where we in our corner of the universe, we see space as three-dimensional and motionless. We see ourselves in a setting of three-dimensional space or volume, XYZ coordinates. And we see time as progressing. Time is always getting later and later and later, but in no specific direction, like a scalar motion. So where we're at, what he calls the material sector, the half of the universe that's actually moving slower than the speed of light, we see three-dimensional space and clock time. Time is always getting later and later and later. But if we crossed over, we crossed that unit speed boundary, that center point, and we moved into this half of the universe that's moving faster than the speed of light, which Larson refers to as the cosmic sector, we would see three-dimensional time, stationary three-dimensional time, and clock space. Space is always moving farther and farther and farther apart. And so again, we have a reciprocal relationship. One side of the universe is identical to the other. One sector of the universe is identical to the other, except that the roles of space and time are reversed. Now, through all of these devices, Larson is able to generate a fecund system to work with, and to then develop, through his powers of deduction, this theoretical universe. I detailed that in about 15 videos that I did about a year ago, called The Outline of the Deductive Development of the Reciprocal System. It goes through all 165 steps that Larson took, from his fundamental postulates to the details of his theoretical universe. Today we're putting in the 4th installment of a talk that Larson gave back in 1979 that is called Science Without Apologies. And this is somewhat of a history of science article. In the first part, he details how the scientists, especially the front rank scientists, have to apologize for their system because they're not able to provide comprehensive answers. They have a different system for physics as they do for atomic physics, as they do for astrophysics, as they do for chemistry, as they do for biology or whatever. All of these different forms of science all have different, kind of different structures, different foundations. And Larson's system, they're clamoring for a generalized system that would help put things in order. But they're not able to embrace Larson's system, A, because they probably don't know about it, but B, it's a threat to them because A, it would require them to admit that they're wrong about their own system, and B, because it would require them to relearn a new system after 30 years of being a professor or whatever, an academic, and then having to turn around and learn a whole new paradigm is usually too much for your average scientist or academic in any field. And so the reciprocal system has never really been given a proper hearing. And then so Larson goes through the paper and kind of explains some of the qualities of his theory. Talks a lot about this expanding and contracting balloon and the scalar motion. So now we're going to get into the fourth part of this paper. And so if you want to start at the beginning of the paper, you want to go back 3 videos. But we'll start right here. In a universe composed entirely of motion, all existing entities and phenomena are either motions, combinations of motions, or relations between motions. It follows that in order to arrive at a full description of a universe of motion, all that is necessary is to determine what kind of motions and combinations of motions are theoretically possible, and what changes can take place in them. In total, this is a stupendous task because of the vast amount of detail into which the development must be carried. But this detail is at a minimum in the early stages of development. The structure of the reciprocal system of theory is therefore simple, clear, and distinct in the very areas in which conventional theory is having serious difficulties, that is, in the physical fundamentals. The correlation between the basic theoretical motions and the basic physical phenomena is clear from the start. The 2 basic physical phenomena, as we observe them, are radiation and matter. The 2 basic kinds of combinations of scalar motions are vibration and rotation. It then follows that the basic unit of radiation is a scalar vibrating unit, and the basic unit of matter is a scalar rotating unit. Now, I don't want to complicate this or get off into the weeds, but some of Larson's followers have disputed what he's talking about here. They have come up with a different model of the photon, not based on vibration, but also based on rotation. So, Larson did have some trouble with his photon, with his model of the photon. The photon is a simple harmonic motion, a wave-like motion, and Larson is basically saying that it's a combination of a translational motion and a vibrational motion, only that the vibrational motion is orthogonal to the translational motion. So the translational motion is like this, and the vibrational motion is like this. And when you combine the 2, you get a wave. But KVK Nehru, one of Larson's followers, altered that, and he proposed a birotation, two counter rotations as the model for the photon. And that's still somewhat in dispute, although it appears as if Nehru's model provides more answers than Larson's. When you turn in and look at like spectroscopy and so on. As I have just brought out, scalar rotation is a continuous inward motion, a rolling motion in the inward direction. We cannot identify inward motion in space as such, but objects moving inward are moving toward each other just as they would if each exerted an attractive force on the others. The inward motion of the rotating units that constitute the fundamental units of matter is, of course, gravitation. Here again, we have a simple answer to a long-standing and seemingly difficult problem. The units of matter gravitate. That is, they move inward toward each other, because that is what they are. The basic units of matter are units of inward rolling motion. Furthermore, this answer to the question as to what gravitation is provides an equally simple explanation of its properties, which have been extremely difficult to understand on the basis of previous theories. Conventional theory regards gravitation as a force exerted by each mass on all others. But that hypothetical force is something totally different from any other force of which we have any knowledge. So far as we can tell from observation, it acts instantaneously, without an intervening medium, and in such a way that it cannot be screened off or modified in any way. These characteristics have been so difficult to understand that present-day theorists have taken the unprecedented step of repudiating the physical evidence and contending that regardless of the observed facts, gravitation must be propagated at a finite speed through a medium or something with the properties of a medium. I've been talking about apologies, but this is more than an apology. It is an outright defiance of the observed facts. Like the answers to the problems that I mentioned earlier, the explanation that the reciprocal system provides for the peculiar properties of gravitation is very simple. Gravitation does not act like a force because it is not a force. The effect of gravitational motion in bringing aggregates of matter closer together is the same as that which would result from a force of attraction, if such a force existed. For purposes of calculation, we may therefore treat gravitation as a force, but this does not give it the properties of a force. Its properties are determined by its true nature. Since each aggregate is moving independently, the results of that motion are effective instantaneously. There is no propagation and consequently no need for a medium. Likewise, the independent motions are not affected by anything that exists or takes place between the aggregates. The brief glimpse of the reciprocal system of theory that I have given here might be described as a qualitative view of the physical fundamentals. A complete theory of the universe must also deal with the quantitative aspects. Indeed, the greater part of the development of the details of the theory is concerned with these quantitative aspects. I therefore want to give also a little idea as to how the quantitative side of the theory develops. The identification of the basic unit of matter is an appropriate example. In this discussion, I have referred to the basic unit of radiation, by its usual name, the photon. But I have left the identity of the basic unit of matter undefined. The reason is that this entity is not immediately obvious, as it is in the case of the photon. The available qualitative information tells us that the unit of matter is a rotating scalar motion, but it does not tell us whether that rotating unit is an atom, a subatomic particle, a quark, some kind of subquark, or an entirely different entity. In fact, it does not tell us whether there is one basic unit from which all matter is composed, or whether there are many different kinds of basic units of matter that can be formed directly from the underlying scalar motion. We can, however, develop the quantitative characteristics of the rotating unit or units, and these will enable us to identify the corresponding physical structures. All of the fundamental scalar units of motion are alike. So all that we have to begin with is the series of cardinal numbers. That is, a combination can contain 1 unit, 2 units, or n units of scalar rotational motion. At first glance, it would seem impossible to build this series of numbers up to there's a typo here, up to the variety, up to the variety of physical phenomena that we observe in the universe. But we have postulated a 3-dimensional universe. And as soon as we begin looking at these numbers in terms of the geometry of 3 dimensions, the possible variations proliferate enormously. If there is only one effective scalar unit in the rotating combination, the rotation is necessarily one-dimensional. If there are 2 units, the rotation can be 2-dimensional. For reasons which are explained in my book, Nothing But Motion, 3-dimensional rotation is not possible. But if the rotational combination includes 3 scalar units, there can be both a 1-dimensional and a 2-dimensional rotation. We further find that geometrical considerations permit 2 of these 3-unit combinations to rotate around the same central point, producing a double structure. This is the most complex structure that geometry will permit, and further additions of scalar motion go toward increasing the rotational speeds. Here, then, we have the answer to the question as to whether there is one basic unit of matter analogous to the unit of radiation, the photon, because an individual unit of matter can rotate in one or all of the 3 available dimensions. There are different kinds of rotating structures, in some of which the rotating speeds are variable. Thus, there are many different basic units of matter, rather than just one building block. There are, however, limits to the total amount of rotation that can be incorporated into any one rotating unit. Speed is added to the double units in increments equivalent to the original unit of this kind. When the total reaches 118 such units, the rotational structure disintegrates. Thus, there are 117 kinds of double units. Similar restrictions to which the simpler units with only one rotating system are subject limit the number of such combinations to 7. Then, because of the general relation between space and time, all of these units are duplicated with space and time interchanged. Thus, there are 117 double units and 117 reciprocal double units and 7 reciprocal single units. Okay, I think we're going to stop right there. If you are as lost as I am, raise your hand. But don't fret about it, because that's the nature of the game here. Sometimes you need to read these things over several times before it clicks in. Sometimes you need to just sit on it and just be okay with not understanding it, and eventually you'll get a clue that will help you to go back and look at it later and maybe unpack a little of it and to understand it a little bit better. That's kind of how you have to tackle learning new paradigms and esoterica, is that just don't get discouraged by becoming confused and give up. Just keep with it and pick up what you can pick up, what you understand, and then just leave the other kind of behind and let it marinate in your head. And you might be able to get a clue here or there that will help you to uncover these things. He got real theoretical there with the geometrical kind of exploration of the possibilities that I didn't quite understand, even though I've probably read this a few times before. But it doesn't mean that it's wrong, and it doesn't necessarily mean that it's right either. But it just means that he just kind of lost me. And, I just recommend that you persevere and just, stay with it, and, recognize that that's part of the territory. You're not going to be able to understand every... You wouldn't even ask for that in mainstream science. If you read a science textbook, you're not going to understand everything that's in it, the first time through. Okay, thanks for tuning in today. We will get to the next part of this paper and finish this paper tomorrow, and maybe talk about it a little bit, and then move along. So please tune in tomorrow, and thanks for tuning in today.